Here's another example of using the definitions of sine, cosine, and tangent that don't depend upon using a right triangle. So the example says, find the sine, cosine, and tangent of the angle in standard position with a terminal point of 4, -5. This is what that's referring to. I'll draw a coordinate system in here. Here is a y-axis, and here is our x-axis, and we'll locate this point for -5. So 4, -5 means over 4, and then down 1, 2, 3, 4, 5. So here we have 4, and here we have our -5. So the point is located right there. And this example is describing the angle that is formed by the x-axis and this segment that goes from the origin to the point for -5. The angle that it's referring to in standard position means it's the angle formed by the x-axis until we come to this terminal side of the angle. So we can call this angle theta. It's a large angle, obviously much larger than would ever fit inside of any triangle. And yet we can find the sine, the cosine, and the tangent of this angle using the definitions as follows, right? We have the sine of this angle is equal to the y coordinate over r, the distance from the origin to the point, and the cosine of theta is equal to the x coordinate over that distance, and the tangent of theta is equal to y over x. Let's use these definitions. In order to use these definitions, we'll need to know what is r, this distance. And since it is a distance, we can use the distance formula. Alright, so r is equal to the square root of this x-coordinate minus the x-coordinate from the origin, so that's 4 minus 0 squared, plus this y-coordinate minus the y-coordinate at the origin, so that's -5 minus 0 squared. And we can simplify this, so we have r is equal to the square root of 4 minus 0 is 4, and then we square it and it becomes 16, plus -5 minus 0 is -5. When we square -5, we get 25. So we have to add these guys together now. We have r is equal to the square root of, let's see, 16 plus 25, so that'll be 20 plus 11, so this is 31. So we have r is equal to the square root of 31. 31 cannot be broken down any further, so the value of r is just radical 31. We can now find the sine, the cosine, and the tangent of this angle. The sine of that angle is equal to the y-coordinate, which is -5, over radical 31. The cosine of this angle is the x-coordinate, which in this case is a 4, over radical 31. And the tangent of this angle is simply the y-coordinate over the x-coordinate. So we have here -5 over 4. And here we have found all of them. And notice that this is an angle that is in the fourth quadrant. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. We're in the fourth quadrant, and since we're in the fourth quadrant, the value of the sine of the angle is negative, the value of the cosine of this angle is positive, and the value of the tangent of this angle is negative, as we would expect. So, this was an example of how we can use these definitions to find the sine, cosine, and tangent of angles that are much larger than would ever be able to work with if we were stuck inside of a right triangle.